My name is Holly Wiley. I'm a global solutions architect here at AWS. I work in the high-tech industry vertical, and I specialize in security. But prior to joining AWS, I worked for a couple of our security competency partners, Splunk and F5 Networks. And I'm really excited here to share the stage with Taryn Peterson. He is the VP of Software Engineering at Capital One, and he's going to share some he's going to share some insights with you about Capital One's guard duty deployment today. So together in this session, we're going to show you how you can leverage AWS services to really understand the disposition of your cloud assets and automatically mitigate threats. So first of all, this challenge really continues to just get harder and harder for all of us in security and all of us who are taking Werner's advice from this morning that we're all in security, and no matter what your role is, you should really be taking this into consideration and incorporate it into your development life cycles. So we have a whole bunch more connected systems than we ever had before. I was just talking to Taryn beforehand, and they really have a lot of connected systems at Capital One. And these devices produce large amounts of data, and we're actually saving and hanging on to that data and analyzing it in ways that we never were able to before. And so this, can give people alert fatigue, right? We're getting so many alerts, and a lot of them are false positives, and sometimes it's hard to know where to invest your time. And then on top of it, finding people who have, the right skills, the researchers, the analysts, the engineers, to be able to do something with these alerts is really difficult to find and hire and retain those resources as well. So we're going to talk about how many of these AWS services are leveraging machine learning to actually be able to identify anomalies, and also how we can use real-time streaming log data with machine learning to do that, and those data inputs to efficiently detect those threats, and then look at how we make sure to have the context that's needed to do automatic remediation of those threats as well. So our CISO, and you may have already heard this today, but Steve Schmidt mentioned his perspective at reInvent last year, saying that, and I got to deliver this internally too to people in his org, so it was an interesting conversation to have. It's people who make mistakes, it's people who use the same credentials in multiple places, and who don't always use a hardware token for MFA. And I was telling Taryn beforehand, I'm going to be trying to do a live demo over here later, and one of the worst parts of it is my machine locks up, that I have to use my MFA token to get back on to show you the email, so I may get to experience that, but I'm using my MFA token. But anyways, so he's saying get the data, get the humans away from the data, and machine learning can help provide threat alerts with very high coverage as well as high accuracy. So we're really trying to reduce those false positives and ease the burden on security professionals, as well as all of those people that are out there trying to build secure environments on top of AWS. And again, a common theme will be making sure that alerts include context, that you don't have to go and correlate that information by yourself to then be able to figure out how to remediate it, because if you're going to automate responses, you need the information to automate that response along with the alert, and really help reduce that manual, repetitive task of having people analyzing raw data and looking at logs. So that lets us start with the data inputs that are used in this threat detection pipeline. Cloud Trail, hopefully everyone's all familiar with that. It's great because in the cloud, you can actually see everything that goes on. Every single API call is recorded by Cloud Trail, so you get to see all of the user activity. And that's one of the most important points, I think, in security. You can't secure what you can't see. And really be able to then also see all of the network traffic that happens in your account as well. And so that's where VPC Flow Logs come into play. And then CloudWatch Logs is really a tool that you can use to send all of these different types of logs into and monitor them in near real time for specific phrases or patterns, and then you can alarm on that information or remediate. And finally, DNS logs are used by GuardDuty, a service we're going to talk about throughout this presentation. And it's really has all of those DNS queries that occur in your DNS resolver inside your VPC. So when you're dealing with potential exfiltration type activities, that's a super valuable input for GuardDuty. Starting with Cloud Trail, it captures that comprehensive history of changes that occurred in your AWS account. It records all of the important information about that action, including who made the request and if it was authenticated with MFA, the services used, and the parameters for each of the actions performed, as well as the response elements. So later when I do the demo, it's really going to be about, since so much depends on Cloud Trail, even if you have good permissions controls to make sure that no one who isn't supposed to can turn off Cloud Trail, eventually there's someone who can, right? And so as sort of a double check, we're going to automate if Cloud Trail is stopped or deleted, putting a Lambda in place to restart that, as well as send a notification. And then VPC Flow Logs. So this is what's going to give you all that good, juicy details about the network activity. So you're going to get the account and the interface and your source and destination IPs and ports, as well as protocol and packets and start and end time. But I think one of the less utilized but really valuable parts of the flow logs is not only whether the traffic was accepted and allowed to flow through by your security groups and your network ACLs, but also the what's rejected. So maybe you're not allowing SMB traffic, but it still might be of interest if there's some file sharing protocols attempted, and that might be something that you want to create alert on in order to identify some unusual behavior. So you can use CloudWatch Logs to send your VPC flow logs there, and then create a CloudWatch metric for rejected SMB packets, and then alarm or automatically take some action on the instance that sent out that traffic. Like, for example, maybe changing the security group to a security group that has no ingress or egress access. So CloudWatch Logs, like I was just talking about with subscriptions, is really a real-time feed of those log events. And you can deliver that to either Lambda or Kinesis to a data stream. And that supports custom processing as well as analysis. And if you need to load your logs into another SIM system, CloudWatch Log subscriptions is a good tool to do that, as well as cross-account data sharing. So you can collaborate with an owner of a different AWS account, or if you do have a centralized InfoSec team, they can use this to collect the logs across many accounts. So diving deeper, now that we know kind of the source data that goes into these more advanced services that AWS offers that use the power of machine learning to detect threats, GuardDuty and Macy. GuardDuty really uncovers, when you think of GuardDuty, think of account compromise or instance compromise. That's really the purpose of GuardDuty, is to identify those kinds of threats. Whereas Macy, on the other hand, is really all about S3. It's about understanding threats to your data stored in S3 and really help you better understand where sensitive information is stored and show you how it's being accessed. So with that said, I'd like to turn it over to Taryn Peterson, who's the VP of Software Engineering at Capital One, to share more about their deployment of GuardDuty. Thank you, Taryn.
Great. Thanks, Holly. So once again, just if you don't know anything about Capital One, because there's a couple of us that are floating around today, Capital One's a diversified financial services company. We have a very big digital presence, and we are in different products, so credit cards, checking accounts, savings products, and auto loans. So think of it in terms of that we have a very large footprint at AWS. If you try to think in terms of root accounts, we've got a couple hundred root accounts. And so think in terms of the amount of data that we're dealing with. You know, really what Holly was talking about really resonates with me around the anytime we can automate the things and make sure that we're applying machine learning on the back end, that allows us to go ahead and detect events sooner and for us to go ahead and close any gaps that come up there. So Guard Duty has been a great tool for us to go ahead and add into our arsenal, and I will talk a little bit more about the details behind it. So if you think in terms of that, what can Guard Duty detect? So if you kind of look all the way over on the left, I mean, if you're looking for an RDP brute force attack, it can go ahead and do that. If it's a matter of that you're looking for some malicious activity around whether it's a whole bunch of known bad actors that are generating traffic, different port scanning that somebody might be doing or trying to install something malicious. And then unfortunately, if you're in that situation of where maybe you have credentials that were compromised, how is it that you could actually find out if somebody's trying to take some credentials, whether they be temporary or permanent, and going ahead and trying to access? So this is really a broad spectrum of what Guard Duty can go ahead and detect. And all the way to the point of where, hey, if you actually have something that's compromised, how would you know that? So the threat detection and notification process, so if you think in terms of that, like for us, we've got a couple hundred root accounts. You can go ahead and just with a couple clicks of a button or using the APIs, you can go ahead and enable this within your accounts. I know for Capital One, how we rolled this out was that we started with a small set of our footprint around the dev test. As everyone went ahead and started to get a little bit more confidence in some of the results that they were going ahead and seeing out, we went ahead and just continued to enable it on more and more of our accounts. This is going through all these different logs that Holly talked about. So when you think in terms of things that are coming through, the VPC Flow Logs are really helpful, the DNS query logs. All those different things are things that Guard Duty is going to go ahead and analyze for you and use that machine learning to come up with threats. You know, for us, one of the big things when we look in terms of evaluating products along these lines is that, you know, everything has machine learning in it today. It's one of those things that a lot of products do. But how is it that it's actually creating actionable alerts, right? So for us to go ahead and get to a point of where we want to dispatch these out to one of our SOC analysts, we really want to make sure that what's being found in this isn't just, hey, a whole bunch of noise that then starts to create the alert fatigue that sets in. And so we've had some really good success so far with Guard Duty. Some of the different things on the known threat side that it can do. So there's different sources that it's already pulling in there, some of the different commercial products. A lot of the things, given the fact that AWS has quite a broad footprint, it knows a lot of the IP addresses and sort of suspected address ranges to look for, different things around the cryptocurrency mining pools, different sources of known bad actors that then can go ahead and feed that into the machine learning and generating alerts to let us know if we see anything suspicious. And then some of the unknown threats, you know, especially when you think in terms of how would you find out if you have some credentials that have been compromised. So a lot of that is where it's starting to get into the machine learning to look at something that's out of the normal, right? If somebody's going ahead and especially across a large set of root accounts, if you see a whole bunch of anomalous, repetitive actions that are happening across those accounts, how could it actually go ahead and figure that out? And one of the things that we appreciate with Guard Duty and a lot of other services is that there's a continued R&D effort that we see Amazon committed to that's going to continue to make this service better over time. So like I highlighted, you know, once you actually find something within the algorithms and starting to go ahead and sort that out, there's a whole bunch of different finding types here, and I won't actually read through each of them. But if you think in terms of that, how you're actually running your SOC and trying to figure out how is it that things are going to go ahead and get dispatched out, you know, here's all the different finding types that you're going to actually see that's getting parsed out of all those logs. So this is a huge help for us to go ahead and have this amount of coverage and continue to see those models improve. Now, this is one that's going to vary depending on how much of your attack surface is actually at AWS and what other asset types you have. But any of the root accounts that you go ahead and have guard duty enabled, you can go ahead and roll those up under one account that your security team can go ahead and monitor. So if you start to think in terms of the patterns of how is it that you're going to go ahead and get at the events, and whether or not you're integrating this into your SIM, kind of like what Capital One has actually done, or whether or not you're actually going to be using the guard duty tools natively to go ahead and monitor. There's a whole bunch of different options here, and one of the things, if you have a large account footprint like what we do, being able to roll that up is really helpful. And so with that, Holly, I think I'm going to go ahead and turn it back over to you.
Thank you very much, Darren. Appreciate it. So now that we've told you a little bit about guard duty and that service, I want to switch back to Macie. So Macie, again, is really all about that data in S3. And it's going to recognize data like PII, as well as intellectual property, and assign a business value and provide visibility into where that data is stored and how it's being used in your organization, and whether that data is being accessed and moved, and it performs up-to-minute data scans. So I like to think of, hey, if you have a bucket that has lunch menus in it, maybe you don't really care what happens to that one, but if you have a bucket that has key intellectual property in it, then you care about that. So understanding that context of whether that data is important or not is going to be the thing that helps us give alerts to the SOC that says, this is one that means something to you, rather than just, hey, this is unusual activity on something that you really don't care about. And it delivers those so that you can trigger automated remediation for it, and you can use custom or prepackaged policies that we have for compliance and audit reports, and you can integrate Macie into your DevOps workflows as well. And also, I want to point out that even if your data is encrypted, it's still worthwhile to have Macie enabled on it, because by its very nature, you probably encrypted it for a reason, and so you may want to see if there's unusual activity, even though you've protected it with encryption. So first of all, the machine learning part of Macie is going to use natural language processing to be able to detect things like credentials and content. So do you have some secret keys in an Android APK, or documents that have app caches persisted, your database backups, as well as it'll do bin and LUN checks to validate that numbers are really credit card numbers. It can be quite difficult to identify credit card numbers if any of you have ever tried to do that before. And it combines, again, that knowledge of, is that data important and how is it being accessed, and provide that context about the users and accounts that might be exhibiting some unusual behavior on that highly critical data. And that's, again, important for cutting down that fatigue and really giving you actionable alerts. So the goal here is, like we like to call it, providing you with 3D visibility into your data. So the object visibility, what's the size and the type and what date was this data created, and then the content visibility of what's in it, again, the credentials, the intellectual property, and then looking at those access patterns and developing a risk profile as well as a relationship with your buckets. And then you can also use Macie to then, once that data is classified, to filter and search on it. And that can be really helpful for compliance. So with GDPR, we have a bunch of new things that we've got to be responsible for. So let's say that you already have implemented and enforced and are trying to enforce policies for disposal of information. Like, let's say you have to validate that your lifecycle policy is actually working to make sure that credit card numbers are removed after 6 months. Macie will allow you to create a search for that to see if your actual policy is working or not. And again, so now we've taken that Venn diagram, right? We've classified the data and we've looked for unusual behavior or that accesses the permissions. And so the user behavior analytics is going to look at all of the API calls that are occurring on the high-value content and try to detect things like sudden increases in that API activity. So this picture here is showing, hey, there's this normal pattern of behavior, and now there's this huge spike. Now, if you can explain that, fine, but that would be an anomaly that it would detect, and it would provide a high-value alert if that's the kind of data that's been classified as intellectual property or credit cards or something like that. As well as, is this now being accessed from multiple locations that are unusual, or at infrequent hours that weren't part of the normal pattern? And so these are the kinds of user behaviors that Macy will be looking for as part of its UBA activity. And I think what's really cool is that when you give Macy, permission, the role to actually look at your S3 information, it then can see all of the gets, puts, and deletes as they're happening on the data plane. So one thing that was really important to the Macy team was that they not create another compliance problem for you, so that information isn't ever written to disk or replicated as part of Macy processing. It's actually doing it in real time in the data plane. And it's also going to correlate events. So it's not just looking for spikes in user activity that are greater than 2 deviations, but it's also looking for Tor access and correlating those two things together, because that would be a really strong indicator that there's a bad actor doing something with that data. So it's going to monitor that S3 access over time, and it'll start to categorize user accesses into groups and peer groups of people that are doing similar things, and that's how it can, identify this anomalous behavior. And one of the big goals for both GuardDuty and Macy in the service teams is to make sure that we're avoiding false positives, that the alerts that you get are meaningful, as well as to tell a narrative, right? To provide some context around that alert that you can use to immediately take action. And if it's the first time you've seen it, maybe you still have to do it manually. But eventually, the hope is that once you've done that manually, you can implement something automated. And after a period of months and longer, you're going to have this nice library of automated remediations for things that have actually happened in real world in your environment. So the thing is, the other challenge that people have is, I think most of the time when people initially create S3 buckets, they put some thought into securing them and providing the right access. It's just, 6 months or a year down the line when there's an acquisition, or you're working with a partner, or you're working with a contractor in another location, then you just change those permissions just for a little while, and sometimes those don't get changed back. And so that's another thing that Macy can help you find out is, are there overly permissive policies associated with an S3 bucket that, based on the context of that original, natural language processing, machine learning that occurred, has classified that as high-value content. So that's an important thing to be able to remediate on, because once you know that that's occurred, then you can, automate something to revoke that policy change or correct that change that made it overly permissive policy. And right now, Macy only supports S3, but on the roadmap, I know the Macy's team vision is to have these same capabilities for EBS and RDS and DynamoDB and EFS and even Glue. So keep a lookout for that in the future. So now that we've kind of found where we're using machine learning to work against these log file inputs, and now we've got these alerts, we want to talk a little bit about how you would use config rules and CloudWatch events to trigger automated notifications and remediations. So A config rule really represents a desired configuration in your environment. And every time something changes, it's evaluated against that desired configuration. CloudWatch is nice, the events, because it happens in near real time as the changes occur, allowing you to take almost immediate action. So when I do the demo, I'll use CloudWatch events because we're going to be looking at Cloud Trail, and you don't necessarily want to wait until a config rule executes in order to have that automatically remediate. So config rule, this is another cool thing in cloud is, there's a CMDB automatically built in that has all your resources in it. You don't have to worry about anything that didn't make it in. And the evaluation of the rule happens either when the change is made, or you can set it up as a periodic rule that occurs, either as small as once an hour or once a day. And you can use these to kick off Lambda scripts. And CloudWatch events, again, is evaluating that in a near real-time stream of changes that's going through your environment. And you can use very simple rules to quickly set up and take action via functions or send it to Kinesis streams. And in this case, it's sending it out to collaboration and communication tools to note that there's been a change. And in this case, the example is a guard duty finding, but it could also be a shield finding or a Macy finding. So I'm going to have to go through the network section a little quickly, but I still want to get it in here. The couple of protecting and remediating threats on the network is really an important part of your security strategy. So we have Shield Advanced as well as AWS WAF. Shield Advanced is available on over 100 edge network POPs worldwide, and it also can protect AWS resources in your region, including elastic load balancers, as well as instances with elastic IPs. Hopefully, normally you don't have instances out there facing with elastic IPs, but I know sometimes you have to, and if those are accepting UDP traffic, that can be especially scary. So those would be the kinds of things that you definitely want to look at using Shield Advanced to protect. And then WAF is really about those layer 7 protections at the edge, and so that can either be against your CloudFront distributions, or it can be against your application load balancers in the region. So there's a whole bunch of types of attacks that we can see at the network. And in this section, we'll really look at everything from, kind of the volumetric attacks that are creating a reflection attacks that are creating a high volume of traffic, that are trying to congest the network and inhibit your legitimate traffic, as well as, WAF to help deal with things like cross-site scripting, where, they're trying to send malicious code to a different end user, or SQL injections, where they're trying to, read or alter or delete your sensitive data. So we have a bunch of layers that we use to protect against DDoS attacks. At the top there, we have internet layer mitigations that happen on our border network. So that's really where we're communicating either via API or BGP with our community, our carriers, and our peers. And we can tell them how they should be handling traffic to our network, whether they should let it come in or not, or whether it should be blocked or allowed. And then next, we have the network layer mitigations. So we've actually built our own proprietary DDoS mitigation system, and it works at the network border. And what's special about it is that it's really tightly integrated with our AWS services. So it knows, it has the context of what type of traffic that service is supposed to accept and what type it's supposed to handle, and that can be really useful in mitigating DDoS attacks. And at the edge, we also have enough, DDoS scrubbing capacity to deal with some of the biggest attacks we've ever seen, which are large. And if we have time in the demo, I'll kind of show you as well what that looks like. We have a global threat dashboard that shows you the last 2 weeks worth of attacks. And then web layer. mitigations, so that's really where WAF comes into play. And if you know that you are a attack vector, you know you have a website, like let's say you're Capital One over here, people actually try to attack them, that's a good candidate for Shield Advanced, because our DDoS response team will actually work with you with Shield Advanced to create custom WAF rules to help mitigate very complex Layer 7 attacks in near real time when they're happening. So in terms of how this works, we first collect kind of two main sources of data. We're getting all the link utilization from the routers. We can see the IP addresses, the protocols, and port data. And that really lets us measure the volume of an attack and detect when link congestion is occurring. And then our second source of data is really from all of the servers that underline the various AWS services. So that really has a lot of proprietary data that's specific about our services, but it includes the full details about the web request itself. So we can look and analyze looking for patterns that wouldn't belong for that particular service, for that particular web request. And then we have to aggregate that data. So there's actually hundreds of metrics that give us a lot of different views into that network traffic. For example, we can calculate the top sources of SYN packets, which can be useful. And once we've aggregated that data, then we can run it through that proprietary DDoS system to be able to understand what traffic might be suspicious. And those systems use machine learning as well to detect anomalies. And when they are detected, this is some of these attack mitigations we do automatically on your behalf. So, so we can have automated workflows that get the source IPs that are involved in the attack and kick off mitigations like for EC2. If there's a DDoS attack against an EC2 instance that's exceeding the network capacity of that instance, then we'll automatically bring a DDoS scrubber in line at the border of our network for that instance. And that can go into effect as little as 7 minutes. And we can also use, automated routing to really absorb large attacks by distributing the load and scrubbing it with the bandwidth and capacity that we have. So then we also do, more fine-tuning on that. We can detect these anomalies with machine learning based on the source IP, as well as the BGP ASN. And we look at the traffic levels, and we know whether they're coming from validated sources or not. As well as with Shield Advanced, we're baselining your normal traffic all of the time. So we're looking at things like HTTP requests per second, and source IP, and URLs, and user agents. And there's two categories of anomalies that we sort of put things in. There's the volumetric, where we're getting abnormal volumes of traffic from either many sources or a very specific source, and then behavioral anomalies, and that's where we're using those HTTP request characteristics and using those traffic patterns to see that they don't conform with what we would consider, based on historical activity, normal, that they're not normal in terms of volume or expected responses. And then there's also deterministic filtering. So we automatically filter out malformed TCP packets. So we're looking for things like IP checksums and TCP valid flags and UDP payload links and DNS request validation. So there's a lot going on here in our DDoS mitigation. And then we basically categorize things as we're doing all of this inspection on whether it's a high suspicion or low suspicion packet, and that's based on whether or not the traffic composition and volume is typical given the source and destination, and whether it's valid for its destination. And then as volumes increase, we can drop those high suspicious packets. So to get all of that, because we're doing all that, kind of behind the scenes, to get that, you have to actually follow our architecture, and it's great because just last week, the the white paper that was a couple years old just got updated on best practices for DDoS resiliency. So I would encourage you all to go ahead and just Google out there AWS best practices DDoS resiliency, and you can see the latest version of the white paper, and it'll basically bring up a picture of like what I have up here. And so for us to do this for you, ideally we want to block these out at the edge. So that involves using CloudFront, our CDN, and Route 53 for DNS. And sometimes people think, oh, well, my web application is dynamic, so I can't really use a CDN. Think of a CDN out there. It can just kind of be that first proxy tier out there for you, sending the traffic back. So you can configure in CloudFront URL path patterns and associated cache behaviors. So for very dynamic web applications that always need to be going back to your origin in order to get information, you can just set the min TTL to 0, and then in CloudFront will make that GET request back to the origin with a if modified sense header. And then WAF, you're going to be able to use that both at CloudFront at the CDN layer, and that's, again, we want to try and catch as many of these DDoS attacks out at the edge. But you can also use it with the application load balancer in the region if you're using a different provider, or you have a different reason not to use a CDN. So the WAF is going to help you, again, with those SQL injections and cross-site scripting and provide you a bunch of rate-based rules. And it's integrated with CloudWatch, so you have nice metrics and alarms. And there's a nice tool called count action. So normally the WAF, you can either block or allow traffic, but I always encourage people to first use the count action. So when you set up your web ACL or your rule about what traffic you want to let in, if you just count, then you're going to get a metric that says, hey, this actually happened, and you can allow that request, and that's what's going to allow you to kind of avoid blocking traffic that you didn't want to. This is a good tool to start out with. And that's for when you're creating your own. You can also use our CloudFormation templates. There's something called WAF security automations, and in that there'll be 2 CloudFormation templates. One's to deploy these 9 rules, web ACLs, out to your CloudFront distributions, and another one is for your application load balancers. So just keep in mind that those are 2 different tiers at which you can apply WAF rules. And this will, help with the OWASP top 10 and rate-based rules. But you also need to consider that the CloudFormation template just gives you the structure for the rules. You still need to go in, like maybe you don't have a SQL database behind this web application, so the SQL injection rule might not be one you want to, you need to use for that. So take the time once you provision the CloudFormation template to go into each rule and think about how your web application works, and then configure that rule in order to have it meet the needs of your application. Another really great thing that we've provided out there is that, to be honest, WAF is complicated, and there's big research teams that some of our partners have had for many, many years working on very sophisticated WAF rules. And so they've partnered with us to offer some of their great rules on top of AWS WAF, and you can purchase those out of the marketplace. And they automatically updates. So when you think about how rapidly attackers can change their approaches, these partners are out there with research teams that are working just as hard on that research and responding in a timely manner. And when you subscribe to their rules, you're going to get automatically updates to the latest and greatest attacks. And these rules, you can unsubscribe to them at any time. So they're definitely worth trying out and seeing if they can help protect your environments. The Firewall Manager is a new service that we started with the San Francisco Summit, I think, in March. And this really allows your centralized InfoSec team to define WAF rules and apply them across many accounts. And this is one of the first security tools that's actually leveraging organizations. So you noted in GuardDuty and Macy, we kind of have this way of subscribing to the hierarchy and setting up who's going to be your central account for GuardDuty and Macy, because organizations wasn't quite ready to do it yet then, but now with Firewall Manager, it's actually leveraging organizations. So you can choose to have your WAF rules applied to all of the accounts in your organization, or you can specify just certain ones. And in the rule groups, you can say, hey, I want the local account owner to be able to override this rule, or this is a rule that I want applied to every CloudFront distribution or every application load balancer regardless. So there's a lot of flexibility in how you can leverage Firewall Manager. So once we've kind of used those triggers that I mentioned before, we went into networking, the CloudWatch events, and the config rules. We're going to talk about how you would send those to tools that you can use to automatically remediate your threats. So that can be, preventive mechanisms for your security boundary services. So WAF, or changing security groups, or changing S3 bucket policies like we saw for the Macy alerts, or you can kind of invoke a deeper inspection of your AWS resources using tools like Systems Manager or Inspector. And Systems Manager is a great tool if you're running a lot of EC2 instances and you need to really mitigate threats at an instance level and be able to perform patching functions. So this is kind of a representative of the way that things have been done for a long time in terms of manually responding, getting the logs and having to analyze and correlate information and going through a really long process to remediate. And the goal in AWS is that since every API call is essentially an event, and you can define these rules, whether it's a config rule or whether it's a rule in CloudWatch like I'll show you, then as soon as that rule is matched, not only do you send an alert, but you immediately start to correlate and remediate based on that event. So at a very high level, and I'm not bagging on interns here, I've had plenty of intern moments myself in my career. And so, I want to show you how you can use CloudWatch events with Lambda to respond to that situation where someone stops a Cloud Trail log, because really that's the foundation of all of this automated remediation and machine learning tools. So give me a second. Okay. So I'm just, here in the AWS console. And what I'm going to start out with is just walking you through two very simple Lambdas. There's not any error checking or anything complicated in this. They're just for demo purposes, but hopefully it makes it a little easier to read and understand what we've got going on here. So this first one is really the notifier, and in this case, it's sending me an email. In the slide I showed you earlier, right? You could have things sending things to Slack channel or to another other tool. But what this is going to do, as I was talking about before, we really want to have alerts and information that gives you the context that you would need to remediate, as well as to understand what's going on. So it's extracting out what happened to what service, where, when, and who, and writing this out to an SNS topic that's then going to send me an email if all goes well. The other Lambda that I'm going to use for this is the Lambda that actually will restart the log. So it's going to Cloud Trail logging. So it's going to extract out the ARN, the resource name of the trail that I stopped, and insert it here into a response that's to start logging with that name. So with that said, now I'm bouncing into CloudWatch and rules. And I'm going to go ahead and create a new rule. And I'm going to look for an event pattern. And what's cool here is that we have a whole bunch of services. So I am just giving you a really simple example of the idea of how this would work with Cloud Trail. But you could also use it, with guard duty is in here, and you can see the list of services is pretty long. But I'm going to just choose Cloud Trail. And then I don't want to do all Cloud Trail events. That would be a lot. So I am looking for a very specific API call in Cloud Trail. And that is stop logging and delete trail. So how would I know these, and how would I know that they're camel case and all that? Well, you get to go to the documentation, sorry. But if it's important enough for Cloud Trail, like Cloud Trail is, then I think it's worth it. So the nice thing down here is that it will give you a little preview of what the JSON looks like for that. And then I'm going to send it a target. And my target is going to be a Cloud Trail restart notice. So that was that Lambda function that I showed you that picked out the who, what, where, when. And then my other one is restart Cloud Trail log 2. I didn't get it right the first time. So as I was mentioning in that other picture, right, that once this event happens, then I don't have to wait for notification and remediation. I can get those kind of simultaneously going. And you see you could continue adding Lambda functions to do more things if you wanted, or Kinesis streams as well here. And I'm going to call this NYC Summit 2018, just so that we know that this is the one I'm creating now. OK, so it's there and it's enabled. So now I'm going to go over to my Cloud Trail trails. And you can see I've set it up. I have different trails for all my different regions. But the one that we're going to mess with here is the one that's in Oregon called Octink POC Cloud Trail. I'm going to click on that, and you can see that it is enabled right now, and it has a logging and where it's going. So what I'm going to go ahead and do is just shut that off here. Okay. So now that is off, and I'm going to give that just a second. And since we're a little short on time while that's doing its thing, I'm going to just wander over here. And I mentioned in Shield Advanced, you would be able to see, kind of all the threats going on. So just in case you don't have, Shield Advanced turned on, here's the number of attacks that have happened in the last 2 weeks, and the size of the attack and volumetric. A real pain point right now is still all those memcached servers that have UDP access. If you have a memcached, get that patched. But it gives you a nice little graph of what's going on. So let's see if I've given it enough time here. I'm going to just refresh, go back. I'm going back to Cloud Trail and my Cloud Trail to see if it's automatically restarted it for me. Oh, whew. That's always nice to see. OK, so it is on. So now let's see if I got my email. OK. Sorry, it's all. So I don't quite see the email yet, but let's go look and take a look and see if my log is there. Okay, so there's today, and so here is the log that came out for this, the stop logging call, and the information about this event. And let me try one more time and see if my email sent yet. It says 2:47 because I'm from Seattle, so. But yay, we don't have to look at yesterday's. We can actually look at today's. So here's, let me make that bigger so you guys can see it. So here's the simple email that got sent to me with the information about the stop logging call that occurred. So again, this is just a very simple demo intended to kind of show you the pattern of how you can do it. But I would suggest that it would be useful to everyone. You don't have to sign up for anything special to implement this. And since all of the other services depend on Cloud Trail working, this is a good thing. And in CloudWatch events is going to let you do this right away. Hang on, let's go ahead and switch back. Okay, how are we doing on time? 10 minutes? Okay. So this is sort of the overview in terms of it doesn't really matter what your event source is. You can, any changes that occur that cause an event, you can send that to Lambda. And I think, the important thing about the value that Lambda really adds to this is that so often our security teams spend a lot of time provisioning and managing servers and patching servers for their own tooling. And when you think about the kinds of access that security tools that run on a server have, if one of those servers is compromised, that can be a real threat to your overall environment. So Lambda also can kind of act as a bit of an auditor. And allow you to bring your own code for auditing across many accounts. And you can use Secure Token Service, or STS, to kind of secure that federated access across your accounts. And then I like to say, if one Lambda won't do, then there's step functions. So step functions is, kind of think of it as a flow chart for your Lambda functions when they're not, side by side like that, but you need one to finish and pass information on to another Lambda in order to do something very complex in a remediation, much more complex than what I did there. Step functions can really be an awesome tool for that. So again, I showed Cloud Trail to CloudWatch events to Lambda, calling an AWS API, and then sending an email. But all of these tools, GuardDuty, Macy, Shield, WAF. Another cool one is if Shield gives you an event that says this IP is a problem, WAF has a really excellent API with a really fast propagation time. So you can take those events from Shield and those bad IPs and add them into your, your WAF blocking lists very, very rapidly. And then if you've got a bunch of, like I mentioned before, if you've got a bunch of EC2 instances and you need to be able to do automated remediation for threats that come from GuardDuty there, then you can use Systems Manager for that. And what's really nice about Systems Manager is the run command. So it's kind of another pain point to have a bunch of bastion hosts or jump hosts that you're using to access all of this stuff, whereas the run command really lets you implement your shell commands or your PowerShell commands through that across a whole fleet or just particular instances. And you can use parameter store in order to store your secrets or your configuration. And now we also have Secrets Manager. So if you need to rotate those, then use Secrets Manager. If you don't, then just use parameter store. And so this is a kind of an example of how you would use the combination of a CloudWatch event with Lambda to kick off Systems Manager. And a document is really just the, what you store, whatever action you want to take in. It defines the actions that Systems Manager is going to do. So if you think of all of these alerts in the guard duty documentation, for example, it'll say all the finding types, and then there's descriptions of how you would remediate those, and a lot of them you could do with Systems Manager. I think over time you'll see us add those automations in for you, but for now we just kind of provide you the tools to do that. So in this example, if you found a compromised instance, then one of the first things that you'd probably want to do after you trigger that Lambda is have Systems Manager go and change the security group so to take away the one that it's right now and put one in that has no ingress or egress access, and maybe it takes a snapshot of the EBC volume and any other things, any information you want to gather about that as well at the same time. And kind of wrapping up, I just want to mention our security competency partners. These partners have gone through some rigorous evaluation in order to become security competency partners. So you can kind of Google that on our website as well and see the different categories of partners. And this is really nice because some of the tools that you're going to want to use that you maybe are using on-prem and you want to use in a hybrid fashion, or you have existing licensing that you want to bring to the cloud, that's possible because of our partner ecosystem in that marketplace. And then finally, there's also some great open source resources. So these are all free. And one of the ones that I particularly want to point out is Capital One has provided access to their cloud custodian, which really allows you to do entire fleet management and use YAML in the configuration files to define all of your policies. But there's a lot of great tools here. So with that said, I'm happy to take questions. I think I managed to get through it all with a few minutes left. So any questions? And thank you for your time. Great. I left that part out because there's so much in here. But yes, you were right on. Depending on whether you give Macy a permission that has access to that KMS key, if you authorize it, then yes, it can classify your encrypted content. But if you don't give it the permission on that, then no, it won't.
And then moving forward, you said you're going to possibly incorporate RDBMS.
That is all their roadmap. Yeah.
So you have protocol calls where you can be stuck in the data at the protocol layer.
Since that's all kind of future vision, I don't know how any of that's gonna work. But your point is well taken. That there'll be things that they have to decide. I just know that their vision is not limited to S3, but I think they've got a ways to go to actually deliver on that. To be honest. Yes.
The WAF for CloudFront.
Yes.
The rate-based rules support exported for. The WAF for regional doesn't support exported for. Is that on the roadmap?
I don't know on that. What I would suggest is there's a forum for WAF. I can try and find out, but I don't know how I would reach you again. So if you place that on the AWS WAF forum, then I think you'll be able to get a response to that. And plus, you'll probably get a whole bunch of people who pile on. And if it isn't on their roadmap, then just seeing your forum entry and a bunch of other people being interested in it may help get it on the roadmap.
It makes it difficult to use the ALB because it's often not in the ALB logs themselves. Exported for is not in there.
Yeah, I can say definitely look out in August and shortly thereafter for some good news on WAF-related logging, because I know there's some stuff coming there. But I would check the security blog for that, because that'll be one of the first places that they talk about that. But I apologize, I'm just not sure whether that question about X-forwarded for the WAF for ALB is in the works or not. Yes?
How do we get data from
Yeah. So with guard duty, we really aren't trying to take over intrusion detection and prevention for everything. We really are targeting that for, hey, we have some expertise in our own logs and the ability to apply some sophisticated machine learning algorithms for those. So I think in terms of guard duty, the scope, as I understand it today, will stay very limited to our services, and we'll look to our partners to fill that larger space. Yes? I don't believe so now, but I know that that there's some things on the Macy roadmap as well to allow you to have more control over that. So I think if you possibly look for that again around the reInvent timeframe, that there's a chance that you might see some improvement on that. Yes.
You mentioned protection of web applications and S3 buckets, but do you have more IDS, IPS-like protections? Like you mentioned IPs coming in from a Tor. Do you have protections across your entire environment? Not just web apps and S3?
Well, I think for guard duty, it is really just looking at account compromise and instance compromise at this point. So it'd be interesting to learn a little bit more about what type of compromise you're wanting us to apply to, and as long as it's in the AWS resource family, I think the guard duty team would probably be interested in understanding better, what you see as missing. But I can't think of anything else on that.
I don't want anybody coming into my environment at all, but Tor doesn't.
Well, so I guess we'd have to look at that as a specific service, right? I think for S3 and for EC2, it's going to protect that. I think there might be other, we'd have to talk about exactly what service you're looking at, because there's likely other limitations to that kind of access for other services. Oh, it should still be able to. Yeah. If it's EC2, then it's sorry. If I mixed web app up in that, no. Anything EC2 should be covered. Yeah. Sorry. Any other questions for us? Okay. Well, again, thank you for spending your evening with us. I appreciate it.